Welcome back to Talk Tensors, the show that takes a deep dive into machine learning research.
That's right.
And today we're looking at benchmark evaluations, applications, and challenges of large vision language models. A survey.
Right.
It's quite a mouthful.
It is, yeah. But it's a really fascinating paper, and I think it comes at a really crucial time in the development of VLMs.
It does feel very timely, doesn't it?
It does. I mean, just in the past few years, we've seen just this incredible explosion of progress in this area.
Yeah.
Going back to models like CLIP and BLIP, which were, groundbreaking at the time.
Yeah.
But now we've got systems like Flamingo GPT-4V Gemini.
It's unbelievable.
It's amazing how quickly things are moving, and this paper does a great job of kind of like capturing that momentum and providing a roadmap for where the field is going.
Okay, but let's step back for a sec for our listeners who might not be as deep in the weeds as we are.
Sure.
What are VLMs and why should they even care?
That's a great question. So at their core, VLMs are AI systems that can both see and understand language. So they can look at an image and then process information from that image, but also process language related to that image.
So they're not just recognizing objects anymore.
Not at all. I mean, VLMs can do things like answer complex questions about an image. They can generate really nuanced captions that capture the meaning of a scene, and even control robots in the real world based on visual and linguistic instructions.
So it's not just image recognition, it's like image understanding.
Exactly. It's taking it to a whole new level.
Now, the paper also talks about this shift from training VLMs from scratch to using pre-trained LLMs.
Right.
What's going on there?
So that's one of the big trends in the field right now. Rather than starting from zero, researchers are now taking these massive language models, or LLMs, which have already been trained on like tons and tons of text data.
Right.
And they're using them as the foundation for building VLMs.
So it's like the LLM is giving the VLM a head start.
Exactly. It's like having this super smart intern who already knows a ton about language, and now you're just kind of like showing them the ropes in the visual world.
I like that analogy.
And what's really interesting is that this approach is leading to like significant performance improvements in VLMs.
Really?
Yeah, because the LLMs, they already have this deep understanding of language.
Right.
So they're able to better connect the dots between what they see and what they understand linguistically.
But how do you actually connect those two things?
Right.
The visual information with the language part when you're using an LLM as a backbone.
Yeah, so there's a couple of main methods that people are using. One approach uses something called a projector.
Okay.
And think of that as like a translator that maps the visual features from an image into a format that the LLM can understand.
Interesting. So it's finding a way to represent the image in the language of the LLM.
Exactly. And then there's this question of how you actually train the VLM once you've integrated the LLM.
Yeah.
And there are two main approaches here: joint training and freeze training.
So what is that like in simple terms?
Okay. So imagine you're training a VLM athlete for like a decathlon.
Okay, I'm with you.
Right. Joint training would be like putting them through every single event at once.
Okay.
Running, jumping, throwing. It's very intense and it can be effective, but it also uses a lot of resources.
So you're fine-tuning all the parts of the model together.
Exactly, including the LLM. Now, freeze training, on the other hand, is more selective.
Okay.
You're basically saying, hey, LLM, you're already a language whiz. We're just going to focus on training the parts that connect you to the visual world. So you're essentially freezing the pre-trained knowledge of the LLM and just kind of tweaking the other components.
That makes sense.
Yeah.
So we've got these VLMs, they're being connected to these powerful LLMs. It sounds like a recipe for like some serious AI awesomeness.
It does, yeah.
But how do we know if these VLMs are actually living up to the hype?
Yeah.
How do we measure their performance?
That's a great question, and that's where benchmarks come in. Benchmarks are essentially like obstacle courses that are designed to test the various skills of VLMs.
So we're not just asking them to identify a cat in a picture anymore.
No. Those days are long gone. Modern benchmarks are much more demanding. They test a wider range of abilities, from understanding complex relationships between objects in a scene to actually generating coherent descriptions of images, and even controlling robots in real-world environments.
So we're evaluating not just their visual perception, but also their reasoning?
Exactly. It's about understanding how well they can connect what they see to what they understand.
Now, the paper talks about 10 different categories of benchmarks.
Right.
What are we actually putting these VLMs through?
Okay, so we're looking at things like visual text, understanding where the VLM needs to extract and comprehend text within an image.
Okay.
Multimodal understanding, so working across different languages. There's even visual math reasoning, where the VLM has to solve math problems presented in a visual format.
Wow, that's intense.
It is, and it just goes to show how far this field has come in terms of the complexity of the tasks that VLMs are now being evaluated on.
How are these benchmark datasets actually created?
So it's a mix of methods. Some datasets are still fully human annotated, which means people carefully create the questions, the answers, and the annotations for the images. This is obviously time-consuming, but it often results in really high-quality data.
Right.
But there's also a lot of work being done on more automated approaches.
Okay.
One common method involves using powerful LLMs to generate questions and answers automatically,
Oh, interesting.
based on the images or captions. And this allows researchers to scale up the datasets much more quickly. But of course, there's always a risk with automated approaches that the generated questions might not be challenging enough or might not accurately test the VLM's visual understanding.
Yeah, that makes sense.
So most automated pipelines incorporate human validation steps where people review and refine the generated data to ensure quality.
So we've got these elaborate benchmarks to put the VLMs through their paces, but how do we actually score them?
Right.
What are the evaluation metrics like?
Traditionally, simple answer matching was the go-to metric. Did the VLM spit out the exact correct answer? But as VLMs have become more sophisticated and capable of generating these more nuanced responses,
Yeah.
that approach has become less reliable.
So just checking for a perfect match isn't cutting it anymore.
Not really.
Yeah.
We now need to assess the VLM's responses in a more holistic way,
Okay.
taking into account things like semantic similarity and coherence. Does the response actually make sense in the context of the image and the question?
So it's not just about keyword matching anymore.
Exactly. And one approach that people are exploring is actually using LLMs themselves for evaluation.
What?
Yeah. So we're leveraging the language understanding capabilities of one AI to judge the performance of another AI.
Isn't that a little bit like having a robot grade its own homework?
Haha. That's a great analogy, and it's definitely a complex issue with a lot of ongoing research.
Wow, so evaluating VLMs is almost as complex as building them.
You could say that, but that's part of what makes this field so fascinating.
Absolutely. All right, let's shift gears a bit and talk about real-world applications. What are some of the coolest things that VLMs are being used for today?
Oh man, where do we even begin? VLMs are popping up everywhere, from powering more intuitive virtual assistants on our phones to enabling robots to actually understand our instructions and interact with the world in a much more sophisticated way.
So we're talking about robots that can understand what we're saying and respond in a meaningful way.
We're getting closer to that all the time.
Yeah.
Take, for example, Screen AI.
Okay.
It's designed to understand user interface components, so it can answer questions about what's on your screen, which has huge potential for accessibility.
That's amazing.
Yeah.
What about applications beyond virtual assistants and robots?
Well, VLMs are also making waves in the world of content creation.
Okay.
We're seeing them used to generate everything from custom memes to entire movie scenes.
Really?
Platforms like supermeme.ai are using VLMs to let users create personalized memes in over 110 languages.
That's wild. VLMs can be funny too.
They can be.
I'm particularly interested in how they're being used in robotics. The idea of robots that can understand both language and the visual world is just fascinating to me.
Yeah, robotics is definitely one of the most exciting frontiers for VLMs. Researchers are using them to give robots a whole new level of capability.
Okay, but be honest, are we talking about robots that can do our laundry and tidy up the house anytime soon?
Not quite there yet, but one area where VLMs are making significant progress is in robot manipulation. So we're talking about robots that can handle objects they've never encountered before.
That's impressive.
Yeah.
How does that even work?
So one example is Vima, which is this transformer-based robot agent that can learn to manipulate new objects just by processing instructions that combine both language and visual information. It's like showing the robot what to do and telling it what to do at the same time.
That's incredible. What about navigation? Can VLMs help robots find their way around in the real world?
Absolutely. We're seeing VLMs used for both zero-shot navigation and semantic cue-driven navigation. That means they can guide robots to specific locations or objects using natural language instructions, even in environments they've never seen before.
I'm officially blown away. But let's be realistic for a second. All this sounds amazing, but are there any limitations to what VLMs can do, especially when it comes to robotics?
Yeah, I mean, there are definitely challenges, and the paper highlights some important ones. One is this trade-off between generalization and flexibility.
What do you mean by that?
Well, some VLM-powered robot systems are really good at performing specific tasks,
Okay.
but they struggle when faced with unexpected situations. Others are more adaptable, but they're limited by the amount of training data they've been exposed to.
So it's like the classic dilemma of specialist versus generalist.
Exactly.
Yeah.
And then there's the issue of embodiment. Fitting these large, computationally demanding VLMs onto robots with limited resources is a tough engineering challenge.
So you've got the super powerful VLM brain, but you need to find a way to make it work on a robot with relatively limited hardware.
Yeah, that's the crux of it. And it requires some clever engineering and optimization to make these systems work effectively in real-world settings without sacrificing performance.
I'm starting to see how complex this all is.
Yeah,
But it's clear that the potential of VLMs is enormous,
yeah.
especially as they become more integrated into our lives.
Yeah, absolutely. I think we're just scratching the surface of what's possible.
It's truly mind-blowing to think about the possibilities.
Yeah.
But I'm also curious about the potential downsides. I mean, giving robots this level of understanding, it sounds like something straight out of a sci-fi movie,
Yeah.
and not always in a good way.
Right. It's important to be aware of the potential risks as well. And that's another area where this paper shines. It doesn't just celebrate the advancements, but it also delves into some of the major challenges that the field is facing.
Okay, let's talk about those challenges.
Hmm.
What are some of the hurdles that researchers are grappling with when it comes to VLMs?
Well, one of the most pressing issues is something we touched on earlier in hallucination. This is the tendency of VLMs to perceive things in an image that aren't actually there. Right. It's like the VLM is seeing things that don't exist.
That sounds a little unsettling.
It can be. And
Right.
it's not just a matter of, the VLM making silly mistakes. Hallucination can have serious consequences, especially if these systems are used in applications where accuracy is critical, like self-driving cars or medical diagnosis.
Oh yeah, I can see that.
Imagine a self-driving car hallucinating a pedestrian that isn't there, or a medical AI misinterpreting a scan.
That's a chilling thought. So how are researchers trying to address this hallucination problem?
Well, they're developing new benchmarks that are specifically designed to assess and quantify hallucination. For example, there's a benchmark called Hallusion Bench that tests a VLM's ability to reason about what it sees and avoid making unfounded claims.
It's like a test to see if the VLM can separate fact from fiction in the visual realm.
Exactly. And there's also a lot of work being done on developing techniques to minimize hallucination during training. One promising approach is using self-reflection methods, where the VLM is encouraged to double-check its own outputs and look for potential inconsistencies.
So we're trying to build VLMs that are not only intelligent, but also have a healthy dose of self-doubt.
In a way, yes. It's all about making these systems more robust and reliable.
Okay, so hallucination is one big challenge. What are some of the others?
Another major concern, especially as VLMs become more integrated into real-world systems, is safety. We need to make sure that they operate ethically and can't be manipulated into doing harm.
Right, you don't want a robot going rogue because someone tricked its VLM.
Exactly. Researchers are developing benchmarks like SafeBench and Safety Bench, which test how VLMs respond in potentially risky situations. They're essentially trying to ensure that these systems can recognize and resist attempts to exploit them. It's like a form of cybersecurity for AI.
Cybersecurity for AI. That's a term I haven't heard before, but it makes perfect sense. Now, what about bias? We talked earlier about the potential for VLMs to inherit biases from the data they're trained on. How is that being addressed?
Bias is a critical issue, and researchers are working on several fronts. They're developing data sets and benchmarks that specifically measure and evaluate bias in VLMs. One example is M-bias, which focuses on identifying stereotypical biases related to factors like gender, race, religion, and so on.
So there's a lot of effort going into ensuring that VLMs are developed and used responsibly. But what about the more technical challenges? Are there any hurdles that researchers are facing in terms of actually building and training these systems?
There are indeed. One challenge is something called multimodality alignment. It's about making sure that the visual and textual information processed by the VLM is properly aligned and integrated. If there are discrepancies between these two modalities, it can lead to errors and even hallucination.
It's like making sure that the VLM's eyes and ears are working in sync.
That's a great analogy. And researchers are exploring various techniques to improve alignment, like using specialized projectors that better map visual features to the language model's understanding.
That sounds pretty complex. And I imagine training these increasingly large and powerful VLMs must be a huge challenge in itself.
You're absolutely right. Training these models requires massive amounts of data and computational power, and it's becoming increasingly challenging. One area of focus is developing more efficient training methods. Techniques like low-rank adaptation or LoRa allow for fine-tuning specific parts of the model without having to retrain the entire thing, which saves a lot of time and resources.
So it's like finding shortcuts to make the training process more manageable.
Precisely. And there's a growing interest in leveraging self-supervised learning, where VLMs can learn from unlabeled data. This reduces the dependence on massive, manually annotated data sets, which can be very time-consuming and expensive to create.
That makes a lot of sense. But it seems like even with those efforts to optimize the training process, there's still the underlying issue of data availability. These models are hungry for information.
That's one of the biggest bottlenecks in VLM development, the scarcity of high-quality, diverse data. As VLMs become even larger and more capable, their appetite for data only grows.
So it's a constant race to feed these VLMs with enough information to keep them learning and improving.
It is. Researchers are exploring innovative ways to address this data scarcity, including using techniques like synthetic data generation. This involves creating realistic but artificial data to supplement real-world data sets.
So it's like creating virtual training environments for VLMs.
Exactly. But while synthetic data can be helpful, it's not a perfect solution. There's always a risk that it won't capture the nuances and complexities of real-world data, which could limit the VLM's performance when faced with real-world tasks.
It sounds like data is the lifeblood of these VLMs, and finding ways to acquire and utilize it effectively is crucial for their continued development.
Absolutely, and the quest for better data is fueling innovation in all sorts of areas, from data collection and augmentation to the use of simulated environments to generate training data for specific tasks.
It's fascinating to see how these opportunities and challenges are all intertwined. This survey paper really does a fantastic job of capturing the dynamic, rapidly evolving world of VLMs. But I think what's most exciting is the potential for these VLMs to be used for good.
I completely agree. While we need to be mindful of the risks and challenges, VLMs also offer incredible opportunities to improve our lives and address some of the world's most pressing problems.
Could you give us some examples of how VLMs are being used to make a positive impact?
There are so many possibilities. One area where we're already seeing tangible benefits is in web accessibility. VLMs are being used to help people with visual impairments navigate and understand web pages more easily.
Oh, that's great.
For example, there are now browser extensions that use VLMs to generate more descriptive image captions, making websites more accessible to people who rely on screen readers.
That's wonderful. What about healthcare? Are VLMs being used to improve medical care?
Absolutely. VLMs are showing great promise in various healthcare applications. They're being used to assist with medical image analysis, which can aid in diagnosis. They're also being used to explain complex medical information to patients in more understandable ways.
I can see how that would be incredibly helpful. Are there any other areas where VLMs are making a positive difference?
The potential applications are vast. VLMs are being used in education to personalize learning experiences in agriculture, to optimize crop yields, and monitor plant health. We're even seeing them used in climate change research to analyze environmental data and model climate patterns.
It sounds like the possibilities are truly limitless. But before we get too carried away with all this VLM excitement, let's take a step back and consider what the future might hold.
That's a great idea. It's important to not only understand where we are now, but also to think about where we're headed. What are the next frontiers in VLM research? What are the potential breakthroughs and challenges that lie ahead?
And that leads us perfectly into our favorite segment of the show, Novel Notions, where we take a leap beyond the paper and explore some wild out there ideas.
Ah, yes, the time for unbridled speculation and brainstorming. It's always a fun ride.
So let's put on our creative thinking caps and see what we can come up with. Building on our discussion of VLMs and their potential for education, what if we could create a visual reasoning tutor powered by AI?
That's an intriguing thought. What do you have in mind?
Imagine an AI system that can observe a student as they work through a visual problem. It could be anything from building a complex Lego structure to solving a geometric puzzle. And then this system would provide real-time feedback and guidance based on the student's actions and reasoning.
I like where you're going with this. The system could analyze how the student approaches the problem, identify common misconceptions, and suggest alternative strategies, all while explaining its reasoning in a way that's tailored to the student's level of understanding.
Exactly. It would be like having a personalized AI coach for visual thinking. This tutor could help students develop stronger spatial reasoning skills, improve their problem-solving abilities, and gain a deeper understanding of abstract concepts.
And think about the potential applications beyond education. Imagine using this technology in rehabilitation settings to help patients regain cognitive function after a stroke or a brain injury. Or imagine the system being used in fields like design or engineering where visual reasoning and problem solving are crucial.
It's incredible to think about the impact this could have. Of course, this is all just speculation at this point. We're in the realm of what ifs and possibilities. But that's the beauty of this field, isn't it? It sparks our imagination and inspires us to think about how we can use AI to make the world a better place.
I couldn't agree more. And who knows, maybe one of our listeners will be inspired by this conversation and take on the challenge of building this visual reasoning tutor. That's what we hope for here at Talk Tensors. We want to spark curiosity, stimulate discussion, and ultimately inspire innovation in the field of machine learning.
Well said. So, dear listeners, if you're feeling inspired, we encourage you to check out the full paper for yourself. You'll find the link in the show notes. And if you have any thoughts or questions, feel free to reach out to us on social media. We always love hearing from you.
Until next time, keep exploring the fascinating world of machine learning. We'll be back soon with another deep dive into a cutting-edge research paper. Goodbye for now.
See you then. VLMs are already having a real impact, and it's exciting to see how they'll continue to evolve.
Definitely, it's a field that's full of possibilities, and I think this survey paper does a great job of highlighting that.
It really does. And you know what I love about our deep dives is that we get to go beyond just summarizing the paper
That's right.
and explore some of the bigger ideas and potential implications.
Absolutely. It's the fun part.
So for our Novel Notions segment today, I was thinking about how VLMs could be used to create something like a visual reasoning tutor.
Oh, that's interesting. Tell me more.
Okay, so imagine an AI system that can observe a student as they're working through a visual problem. Like building a complex Lego structure or solving a geometric puzzle. The system would analyze their actions, their thought process, and then provide real-time feedback and guidance tailored to their specific needs.
That's a really cool idea. It's like having a personalized AI coach for visual thinking.
Exactly. The system could help students develop stronger spatial reasoning skills, identify common misconceptions, and even suggest alternative approaches.
It could also explain the underlying concepts in a way that's adapted to the student's individual learning style.
Right, because everyone learns differently, and this kind of personalized feedback could be incredibly beneficial.
Absolutely. And think about the potential applications beyond education. This kind of technology could be used in rehabilitation settings to help patients regain cognitive function, or in fields like design and engineering, where visual reasoning is so important.
The possibilities are really exciting. Of course, there are a lot of technical challenges to overcome,
Oh, definitely. It's not something that we can just build overnight.
but it's a great example of how VLMs could be used to create something truly innovative and impactful.
I agree. It's a vision worth pursuing, and who knows, maybe one of our listeners will be inspired to take on this challenge.
That's what we hope for here at Talk Tensors, to spark curiosity and inspire innovation in the field of machine learning.
Well said.
So to our listeners, we encourage you to check out the survey paper for yourself. The link is in the show notes. And as always, feel free to reach out to us on social media with your thoughts and questions.
Until next time, keep exploring the fascinating world of AI, and we'll be back soon with another deep dive into cutting-edge research.
See you then.